In the last video, we started work on defining what methods were, and we started work on creating the methods. So let's continue on with methods. Okay, so we've defined the type of information that's coming back, and we've also defined the actual value to be returned back. So next we need to do is I'm going to take out the print line there. And I'm going to put int high score equals, because the other thing you can do is you can assign a variable to a method result. So what we're doing is we're saying take the value that is returned to us from the method calculate score and put that into the variable called high score. We can then do our system output, but final score will be actually the variable high score. And likewise for here, what we could do I'll delete that out. Same deal there, so we can run that just to confirm that it's working. We've still got the same scores, but now what's happened is, as you can see, there's no printout in this entire method. So the result of our calculations is being sent back automatically from the calculate score method, and because we've put the int high score equals and then the name of the method and then the various arguments that we've sent to it, that value that we return, in this case final score, is being sent back and placed into the high score variable. Pretty cool, as you can see, because it really means that you can create methods to do calculations and just to send back the result of the calculations, making your code a lot easier to read rather than having to put all this calculation code, perhaps in an area that you didn't want it to be in. Okay, so it's time for a challenge. I'm going to make a bit more space. Okay, so here's the challenge. So that's it. You need to create a method called display high score position. So it should receive a player's name as a parameter, and a second parameter should be defined as a position in the high score table. So what you need to do in that method is display the player's name along with the message, words to the effect of, player name managed to get into position, and then display the number they received, the number they got, the position number, then a further message on the high score table. Then create a second method called calculate high score position. It should be sent one argument only, in other words, have one parameter, which is the player's score. It should return an int. Now the return data should be the number 1 if the score is greater than 1,000, number 2 if the score is greater than 500 and less than 1,000, number 3 if the score is greater than 100 and less than 500, and in all other circumstances return 4. So you need to call both methods and display the results. Any name, you can come up with any player name, but a score of 1,500, 900, 450. So in other words, you'd call the various methods 4 times to come up with this. And just to be clear, the display high score position is a void method, so it doesn't have to return any data. And incidentally, just while I remember, a void method can also be known as a procedure. And a method, generally speaking, can also be known as a function. So you might hear me using those terms interchangeably throughout the course. Procedure would generally mean a method returning type void. Okay, so see how you go with this challenge. Go away and try and see how you get on. And once you're ready, come back and I'll show you my solution. Okay, so let's have a go with the solution. So firstly, display high score position. Player's name as a parameter and a second parameter as the position in the high score table. So we'd create something like public, static, and there's no return type, so it's going to be void. So the method name is display high score position. The parameters are going to be, the first name is the player's name. We're going to use a string data type for that, and we'll just call that player name. Second parameter is a position in the high score table. Let's use an integer for that. It wouldn't really matter what you use, but probably integer would be the most efficient. And we'll call that high score position. Then what we need to do is display the message. So it would be displaying the player name firstly, plus managed to get into position, and I'm just going to do that to make it a bit more readable, plus we need to add and the high score position. And notice also with the variables, if they've been used, they're in dark black. If they haven't been used yet, they're in a light grey. This is a great way of figuring out whether you actually need to use, whether your variables are being used properly or not. So I'm going to type in plus the high score, plus on the high score table. So that should be that one. So for the second method called calculate high score position, we need to do a public static. Now this one we needed to return some data, so the return should be returning an integer. Therefore it won't be void, but it'll be int, which is the data type. Calculate high score position. And it needs one parameter, which is an integer, the player's score. So we're going to call that int player score. And we need to have some calculations here to know what to return. So we're going to put if player score greater than 1000, code block, we're going to put return 1. Else if player score greater than 500 and player score less than 1000, we need to just return 2. Else if player score is greater than 100 and player score is less than 500, return 3. Then in all other cases we need to return 4, so that will be just one final else without an if, return 4. So that should be that method. So we've now fulfilled I think all of that. What we need to do is we need to actually call these methods with various parameters. So what we're going to do is start off with int. We'll call it high score position equals calculate high score position. We're going to pass the first one, which was 1500. And then we want to actually execute the second method, which is display high score position. And we're going to pass the name Tim. And we also, as the second argument, is going to be the high score position. Okay, then next, we're not going to redefine the data type, so I'm just going to copy that. And we're going to put the second one, we're going to pass, we needed to pass 900. And we'll put Bob for that one. The third one, we need to use 400. And we'll put Percy. And the fourth one, 50, Gilbert. So that should be our 4 arguments, 1500, 900, 400, and 50. So you can see what we're doing is on the first line, we're calling the calculate high score position method to return the number. And then we're executing the second method. And notice we haven't got a type because we're not setting it to a variable or anything like that because it's of type void. We're just physically calling the method like you can see there on the screen. So now if we run that, we should hopefully get 1, 2, 3, 4 showing because we've put these in the right order of 1500, 900, 450, which should be the 1, 2, 3, 4. So let's try that. Tim managed to get into position 1 on the high score table. Bob managed to get into position 2. Percy managed to get into position 3, and Gilbert managed to get into position 4 on the high score table. So it seems that our code worked. So what I want to do is just correct what was actually a flaw in the original code that I've developed for this lecture. I'll just tab over to a discussion that a student left. And you can see Julian Brown left a message to say that there's a logic hole in your challenge code. And he's actually quite correct. So, and what he goes on to say is after the first if statement, the second one does not need to test for less than 1000. By doing so, a score of 1000 would slip through and return a 4. So in other words, what I've done, and we go back to the code and have a look, well, I actually replied here and actually said, the challenge as I wrote it in the lecture was as follows: to return 1 if the score was greater than 1000, return 2 if the score was greater than 500 and less than 1000, and return 3 if the score was greater than 100 and less than 500, and otherwise return 4. So my code actually works as per the challenge, but what is quite correct that Julian points out, and also Michael's pointed out a little bit further down as well, is that there is actually a logic hole, because if we pass a score of exactly 1000 to this routine, or a score of 500, or even a score of 100, we get the wrong results. So there's actually a bug in the code. So let's just go back to the code, and I'm just going to run it so you can actually see what the bug is, and then we'll actually fix it just so you know how to go about doing that. So these examples have all worked without any problems, and that's because they are working within the constraints of the if and the else ifs that are here. But what we haven't done is tried to actually pass a score that's exactly 1000, that's exactly 500, and that's exactly 100. So for example, let's do one that's exactly 1000. High score position equals calculate high score position 1000. And we'll display high score position, and we'll say it's Louise, high score position. So what should happen in theory is that the way we've set it out, if the score is greater than 1000, that should be really greater than or equal to 1000. And likewise for this one, it should be greater than or equal to 500, and less than 1000 should be greater than or equal to. Because in reality, we don't really want the score of 1000 to be number 4. We would want to say that, okay, they've scored 1000 or more, they should really be in position 1. But if we run this code as it is now, we'll find that 1000 will actually be returned into position 4. So Louise, even though she managed to score 1000 points, has got to position 4. And just confirming the reason for that is, in the actual calculate high score position method, I've got if player score is greater than 1000 to return 1. Then the next condition is if player score is greater than 500 and the player score is less than 1000, return 2. So can you see the logic there? The first test is actually checking to see whether the score is greater than 1000. The second test is checking to see whether it's greater than 500 and it's less than 1000. So consequently, if the score is exactly 1000, it actually bypasses all of these. It just goes down to the final else and returns 4. So what we should really have done there, or what I should have done, is put equal there. So if the player score is greater than or equal to 1000, that's going to be position 1 in the high score table. So that's just that change. And likewise, if player 2, if the score is greater than or equal to 500 and it's less than 1000, to return 2. And the last test would be if player score is greater than or equal to 100 and less than 500. So if we do that, that should actually fix all our logic problems. So if we just actually run that again, we find that Louise managed to get into position 1 on the high score table now, and that's because we're now correctly checking to see whether the score is greater than or equal to 1000. And likewise, if I just do a couple more copies here, and the next one we'll do a test for 500. In the previous version of the test, we only were testing for greater than 500 and then less than 500 the next one. So that would have slipped through to position 4. That should now work. So if we change that to 500, Carol. And the last test, that also had a similar problem. We're only checking to see whether the value is greater than 100. So we should really put greater than or equal 100, which we've done there. So that should now work okay. So we put Frank. So now if we run those, they should all be in their correct positions as well. So we've now got Louise managed to get into position 1 on the high score table, Carol managed to get into position 2, and Frank managed to get into position 3. And just as a recap, if I actually remove the equals on all of these to have the code as it was before I made the change, you'll find that they'll actually be in a different order. The last 3 all went into position 4 automatically, Louise, Carol, and Frank, when really they shouldn't have because of the bug that I had in the code. Let's put that back again. Put the equals back in and run that again. We've never got them correctly in the right positions. So thanks to Julian and Michael for pointing that out, and that's the correct code now. That's fixed that logic problem that they found, and hopefully your code's now a lot better as a result of that. So keep that in mind. That is actually a really important thing to make sure when you're testing your ranges that you include everything. Now that clearly there was a bug here that I actually didn't check to see whether the score, that all scores within that particular range were actually correctly being identified, and they weren't in this case. There was 3 scores that was slipping through the cracks. So there you go. That's methods. I hope you've got a lot out of that, and I'll see you in the next video.